Hello and welcome back to my channel. In today's video, I'm going to show you how to upload the software needed to run the TEDAC on the Arduino. This is going to be two different videos because if you build the TEDAC with port expanders, you are going to need to do it differently. So this only applies to those who build it with shift registers. And the next video will be the one that I'll explain how to do it with port expanders. So if you build it with the shift registers method, you will need a software called mmjoy. And there's a link in, I added a new, well, I actually modified my website to include files and links. So if you go to my website, and again, the link will be in the description, files and links, I added this miscellaneous part with the required links. I will also include these links in the description, so don't worry, you don't need to go to my website. But you will need the GitHub of the developer, and also there's a link for the latest software version, because for some reason, I mean, this is a program that has not been maintained, and the latest version is from 2016. However, it's not found in the GitHub. You will need the GitHub for the wiki section. There's some information that you need from there. But the latest version of the software, there is a link to a drive folder, and this is the one that you will need to download. So these are the two links, and then there's another one that's a direct download from my website, because this joystick tester the developer's website just went recently offline or expired or something, so you cannot find the software from his website. But I mean, this is a freeware license, and in his documentation, he says it's free to share as long and distribute as long as you don't make any profit. So I just upload it to my website, so you can download it from here. This is a very useful tool to test any type of joystick or gaming device. But we will get to that later in the video. For now, you need to download this file. This is a compressed file, as you can see, and there is no installation file here. It's just an executable, so you just decompress or uncompress the folder, and you can work with it straight away. So I did that in my documents folder. This is the one. And here you have all the files that you need. You are going to need to run the mmjoy setup.exe, and it will require you to provide admin rights. Yes. And first thing you may want to do, this will load by default in Russian, but here you can change the language. And you need to go, first thing of all, you need to go to the firmware tab here, the last one. So the first thing that we are going to do with the Arduino is actually replace the original Arduino bootloader with a firmware file. This does not contain any information on the buttons. This just allows this program to assign buttons and access and everything. And it's not going to use the original Arduino software or firmware that it's preloaded in the Arduino boards. This is a step that can be reversed, but yeah, I've managed to break one of these boards, so it's not easy to do. Also to reverse it, I mean, it is once you get the hold of it, but just bear in mind that once you change this firmware, more likely than not, you will just stick to that. And if you want to get back to the original Arduino, there's some steps to follow. I'm not gonna go through them because that's not the scope of this video, but just so you know, this is going to change how the computer reads the Arduino board. So now I have one not yet plugged in, but I have a brand new one. And first thing that you need to do is see what is the COM port it connects to. So you want to go to the device manager by right-clicking here, and well, this is in Spanish, but you will find the device manager here. And here you have a section that says COM and LPT ports. Expand that. There's a couple of ports already in mind, but the important one is when I plug in the Arduino, and I'm going to do that now, you will see one port. So I just plugged it in. Okay, it didn't record. There it is. Okay, let me just close this USB. And as you can see in the COM section, it added it says Leonardo because it's the same bootloader, which is actually the Pro Micro that I'm using, and it says COM26. However, this is not the one that you need to know. We need to put the Arduino board in a programming mode. It's called DFU mode. And to do that, you just short 2 pins of the Arduino, and you just have to do it like a quick short. It doesn't need to stay on. I'm using metal tweezer to touch the 2 pins together, and those pins, I'll show you a picture in the screen, are the reset and ground pins, which are next to each other. You can use a piece of wire or a knife or something metal to short them very briefly, because the moment you short them, it's going to put the board in DFU mode, which is what we need for to install the firmware for MMJoy. But that state only lasts like 8 seconds. So you need to be quick about. I mean, the only thing you need to know is the COM. You'll see when I put it, it will change this Arduino Leonardo to Leonardo bootloader, and it will give me a COM. So I'm going to just do that, connect reset and ground, and show you. See, Arduino Leonardo bootloader, and the bootloader COM port is COM24. Okay, so now that I know that, and as you heard, it just reset, it just a few seconds, but it's fine. I just needed to know that the COM port for the bootloader is 24, so ignore this 26. So now I can close this, I don't need it anymore. And here we have to do several things. So first of all, update the COM to 24, which is my port. Yours can be a different one, so that's why you need to check yourself. Then firmware file, you need to browse for wherever you downloaded the MMJoy folder. So in my case, it's in my documents and MMJoy folder, and there is a folder here called firmware. So this software allows several boards. The one we are using is a Pro Micro, so it's this one here, Atmega 32U4. You have to select this hex file, right? And then the chip Atmega 32U4, bootloader type Arduino, and the COM port 24. And one thing that is also useful is this auto start upload firmware when COM port is active, because otherwise we will need to active the bootloader there. We will have to put the Arduino in DFU mode again, and then click upload firmware. If we click it, this will do it automatically as soon as it detects that the COM24 is active. So I'm going to do that right now. And there it is. And you see that the screen opens up and loads everything. So I don't know if you noticed, but I have several devices here, and it just added this one. This is the new one. So first thing that we need to do is load the proper information for this board. At this moment, if I open the USB gaming device, you can see I have my left console, my MPD, my TEDAC, but we have also this MMJ reset, whatever. This is the new board, and we need to give it a name and also a BID and PID. It gave it very well this standard default 888 BID and PIDs, and I'm not going to go into detail about BIDs and PIDs and what they are and what do you need to do. I would suggest to just copy the numbers that I'm going to put, which are VID 2355 and PID for the TEDAC is 8053. And then I'm also going to change the name to AH64. What do I usually put? Hyphen here, and then the DAC. Then we select in the scheme, we also select the ATmega32U4 one. And one thing that we need to do is select, we don't have any device selected now. So that's why it's in this icon is in red. The moment we and these buttons to load and save sets to the device are grayed out. That's why they are, because we have not selected a device yet. And also we have these buttons to save anything that we do to a file in your computer. And it's a good thing to do that quite frequently so you don't lose any configuration. Although if you loaded it to the device, you can then recover it. So we select the new board and click Save Sets to Device. And you'll see that once it's loaded, it will reset and it will appear here. It will appear here as a new TEDAC. And it might not appear actually because I have mine already plugged in. So I'm gonna unplug mine for the time being, because it's conflicting. But now you see I have unplugged mine, so this is the new board that I'm creating. As you can see, when you select it, it turns blue, means you can configure. So the next step is going to be setting up both the buttons and the analog axis. I'm not going to do it because I don't have this board connected to anything. I'm just going to show you how mine looks like and what you need to do. So let me just unplug this one that we just created and plug my own TEDAC back in. So this one that you can see here is the one that I built, and this one is fully built. We're not going to write anything to it because it's already set up and configured and anything, but it will it will serve me to show you what you need to do. So you select it, turns blue, and then the next thing, easiest part would be probably the joystick buttons. So let's go to the buttons part, and we will do the access later. So buttons, tab, and as you can see, there is a total of 132 buttons here. These are the physical buttons that you have connected them. So first thing that you want to do is say how many shift registers do you have, and in this case we have two different lines or rows of shift registers. If you remember, we connected 4 registers in the left hand grip and then 6 in the right hand grip, including the additional, there's 3 in the right hand, inside the right hand grip, and then there's additional 3 that are in series in line inside the enclosure for the TDU. In my case, because I used PCB version 2.1, which needed a couple more shift registers. So what you need to do is select the chip, which is 74HC165, both of them, because we are going to be using the 2 lines. If you remember, we connected it to 2 different data lines, data pins. And here we need to say which are the CS and data pins. These pins are, CS is what we called latch. And if you remember from the previous video, latch was pin 14, if I recall. But so this is why you need the GitHub of the program, because there's a wiki page in here. And if you go to the wiki, and the section that you need is the compatible base boards. In this, you will have these schematics of ProMicro. And if you remember from previous videos, pin 15 is the clock, and we cannot change that in the software. There is no option to select the clock, so that's why we had to connect the clock of the shift registers to the clock pin of the Arduino, which is pin 15, is this one here. Pin 14 is where we connected both latches, so latch from both lines of shift registers, but for some reason this program doesn't use actual port pins. It has this A2, A0, A1, A2, A3, and this is why you need the wiki, because you have the mapping here. So pin 14, pin 14, which is this one here, is actually B3 in the software. So this is what you need to remember. So latch is going to be B3. So here, latch is the same as RCS. It's the same. If you remember, they have different names. This is what you need to set up as B3. And then the same for the other shift register. And then we have the two data lines from the shift registers. Left one we connected to 10 and right one to 16, or the other way around. You do need to know which way you did it, but I just don't remember. But don't worry, we don't need it. Just check out which ones you did, because you will need to provide how many shift registers there are. So let's suppose that we did left to pin 10, which is B6, and right to pin 16, which is this one here, and is B2. So let's say B2 here, for instance, and B6 here. And something you may want, so now that we have this, so we said B2 is right hand. So in this case, we need to say how many shift registers are there in that line. So in this case, it would be 6. And in the left hand, we had 4. If you build this with version 2.0, which doesn't use shift registers for the TDU, but it uses a button matrix, it will be probably just 4 and 4, or even 3 and 4. You need to know how many shift registers you used and in what line, where did you connect them. So, but let's assume in this case, I had the 6 in B2 and 4 in B6. And at this point, if we are correct, we can save the sets to device. I'm not going to do that now. But if you do that, and if you did it correctly, what I'm going to do is load sets from device in my case, because I'm going to load whatever I did load. So as I said, this is already working unit. So I'm going to see what did I load in here. When I load it, it's going to check what it was. So in my case, I have it backwards. So you see that these pins were the other way around. And I remember when I did this the first time, I got confused and had this in B2 and this in B6, and I was missing some pins, to the point, some buttons actually, to the point that I even opened up the grip thinking I had some bad connection, something not properly soldered, so it was a pain in the neck to figure out. And the thing is that I had this reversed, so the program thought I only had 4 shift registers in the right hand, when in fact I had 6. That's why it was not registering all the button presses. So make sure you know which pin are you using for which side and how many shift registers do you have. So now that I have loaded what I had, you will see that if I press, I mean, you're not seeing, but I can tell you that I'm pressing some buttons in my TEDAC, and you can see them register in the right, in this left section. All these buttons that I'm pressing, it only means that they work and the program is registering it. But now we have to tell them, to tell the system, what do we want this to be? One important note is that you can see there are a couple of buttons that were pressed. In particular, this 30 and 31 was a 3-position latch switch that I had in one of the positions. So I just put it in the center and then it disconnects. But this one here, if I move it, this is the day, night, and off rotary switch that we have in the TDU. And since every single position has an active position, there's no way to disconnect this switch, right? So there's always going to be one of them active. And why I tell this, because this is a problem. We have to now say, so for instance, the IAT switch, the one on the left-hand grip, top left corner, is a 3-position momentary switch. So if I go IAT, it says 53. If I go down offset, yeah, that is 52. But let's say that's the physical position, so the physical position of the switch. If I want this to be actually button 1 when I press, because I do have an order I usually like to do from top to bottom and from left to right to assign buttons. So IAT for me is actually button number 1. And as you can see, we have it in this section here. This is the one section that we need to assign all the buttons that we use. We could have 100 buttons connected and only need 3 of them, and then we would put just 3. Obviously, that wouldn't make any sense, because why would you wire 100 buttons if you are not going to use them? But this is what I mean. If you had 100 buttons and only program 3 of them, that device, it would show only as a 3-button joystick. So if you can see, my IAT, which is number 53, is my button number 1. And to do that, you just double click. However, there's a problem with this software, and it's a minor problem. It's not something that is very concerning, that if there is an active button here, it's going to automatically assign it. So if I double click here, you see it just automatically, it didn't let me do anything because it automatically assigned number 1. If I go to the next one, it does the same because this is active. So there are 2 ways you can overcome this. Let me load the sets again so I have this reset. There are 2 ways you can overcome this. The best one for me, if you have not closed the TEDAC yet, and it's still, you still have access to the wires, and if you use a connector for the rotary switch, like a DuPont connector, something like that, something that you can disconnect that one switch, that would be the easiest one. So I cannot do it because my device is already closed and complete. But if you could disconnect the rotary switch, even just the ground pin, this would turn off. And in that case, if this turns off, everything is gray, right? You can just double click and then press the button and it will assign. And you have to do that all the way until you have covered all the buttons in your TEDAC. And as you can see, in my case, I have up to 81 buttons. If you cannot, because for instance, let's say I have to modify my unit, which is already closed, and I don't have access, easy access, I would have to remove all the screws and everything. It would be a pain to do that. The other thing you can do is if you disconnect the unit, so I just unplugged it and plug it back again. Now it's, if I don't select it, so it seems like it's selected, but it's actually not, and it's red here. Now I can manually select everything. This is a little bit tedious because what you would have to do is actually select it and then press every single button and write it down in a notepad or something like that, and in the order that you would want, if that is something that you are concerned about. So you would select you will press every single button. So my order, for instance, is 53, 52, and then 54, 60, 55, 61, and so on. So I would press every single button in the order that I want and see what number lights up, and then write that down in an Excel file or in whatever you want to do it like a notepad, Word document, whatever. You put all the button numbers and then manually you disconnect this, you reconnect it again so it's not selected, right? Now it's not there. And then you manually input the button numbers here. And once you have done that, you select it and then save sets to device. So that's how you see how you would do it if you had the unit close. And that's basically it for buttons. It's very simple and it's already done. Again, I would recommend, especially once you have done all this work, save everything to a file just in case for whatever reason you lose it. And then the next step would be joystick access. So if you can see here, we have 4 analog inputs, and that is X and Y for the analog joystick, and then a slider and a dial for the level and gain knobs. Obviously, I already have them where they need to be, but what you need to do, let me just connect the other one. So this is the new board that I connected earlier. Load sets from device, and it will be blank because there's nothing in this one. As I mentioned, this is a brand new board. So what you need to do is select internal sensor. This is the option for the analog joysticks that we have used. There's 4 of them, as we have mentioned. Then the assignment, it's going to be X, Y, Z, sorry, not Z. I like to use, well, I mean, you can use whatever, to be honest, but I like to use slider and dial. Doesn't really matter the order at this point. Then you need to connect the MCU port. And again, this is what we need to use. If you remember, we connected the analog inputs to A0 to A3, and these are F4, F5, F6, and F7. So at this point, just do that. F4, I mean, you can type it in. F4, F5, F6, and F7. Then I think at this moment, that's all at this point for now. And you would save this sets to device. And actually, you may actually not need to save it yet. So I'm going to disconnect. Let me just very quickly repeat. So source, internal sensor, the MCU ports would be F4, F5, F6, and F7, and then you have to give it the assignment. For now, that's all you're going to need for now. But now I'm going to disconnect the new board and reconnect my own TEDAC, the built one, because we had analog inputs connected to them. So load sets from device. This is what I have loaded. I did it the hard way, meaning I changed the MCU port, but the easiest way to do is just leave F4, F5, F6, and F7 in this order, and then move each analog input at a time. So for instance, now I'm going to move the level knob up and down, and as you can see, the slider goes up and down, these 2 values. So this is the actual value, and this is what it's converted in I don't know how many bits. I think that's 8 bits. So in this case, because I changed the port side, it's in this order. But originally, if you kept the order that I said for F4, F5, F6, and F7, you would see this number moving. And since I'm moving the level knob, it doesn't make sense. This would be X at first. We set this as X. So what you would do is just change it and say, okay, I'm moving the level knob. I want this to be the slider, then change slider. I would move then the next knob, the gain knob, and see this one is moving. This is a 5, so in your case would be here, for example, and this can change depending on how you connected them. So it would be moving this. You select then dial here, and then you move the analog, the joystick up and down, which is the y-axis, and you would see which one is moving and select that as y, etc. And let me just reset this. Once you have selected properly what each analog input is, so in my case, I already have this in Y, so you can see I move up and down. This is the one that it's moving. There's something else that you need to do, and that is check if the order is, the direction is correct. So for instance, you can see here my x-axis. I checked it says inversion. That's a really bad, I think, bad translation. But I have the x checked here. And why is that? So if I open the USB, the gaming device in Windows, and I don't know if actually I'm going to be able to, because it's okay. Yeah, it does. Sometimes it's failing me. I don't know if it's because I have so many devices. But the thing is that when I was moving X, so I moved X to the right and to the left, right, left, it was doing the opposite. So I moved the joystick to the right, and the cross moved to the left. So we needed to invert that, and you do that with this check. And as you can see, I didn't do anything else because everything else, my knobs are properly, and the y-axis was fine, so I didn't need to invert anything. But you might have to invert different things, so that's what you need to check. Then we have the filter. I've set this up for the maximum. This, what makes is, you see these values dancing a little bit. That's the nature of analog inputs that are kind of, let's say, cheap or low quality, which these are very cheap analog inputs. So they dance a little bit around. This filter, what does is clean a little bit the output of that flickering. And for the Y and X axis, you want to do auto with center in order for the program to calculate where the center is and also where the maximum and minimums are. This has a minor drawback, and this setup, what it does is that first time you plug it in, it's going to be jumping around all over the place. But it's just because the system doesn't know where the max and minimums are. So the first time you plug the TEDAC in, every time you plug the TEDAC in. So if your computer is off and you turn it on, it will happen the same. But the first time you just need to roll it around and leave it to the center, and then it will know where the center is and work as expected. So let me show you. I just unplugged my TEDAC, unplug it back again. And actually, it did save properly. But sometimes it needs to know where the center and the max and mins are. So you just roll it around, and that's it. And that would be all, I think. There's nothing else to explain. Obviously, every change that you do, save a copy. You don't need to be copying it to the device every minor change that you do. I just feel it's safer, and you can then test. But yeah, you could set everything up and then upload it just once, or just do the opposite. Just set small things and then upload, then set the next thing and then upload, whatever you feel more comfortable with. So we are done with this. We're actually done with the build of the TEDAC and the programming. One thing you may want to do once you have uploaded all your setups is download this software that I mentioned, Pointers Joystick Tester. This is a very nice software to test, because if you notice, the Windows device you can actually only see 32 buttons, and it doesn't mean that there's only 32 buttons. It means that Windows only displays up to 32. But if you want to test, so now if I click any buttons, and actually it doesn't work very well for some reason in my case. I do need to format the computer, and maybe it's because I have a lot of devices. But if you check the joystick tester, this program is a very neat one to see how it works. So I have all my devices here. If I select the TEDAC, then you can see all the buttons, and I can press all the buttons, and all of them are displayed. So yeah, you can see all of them working and make sure that everything works. The only thing that's left to do would be to map this in DCS. And I think I'm actually going to do a different video to show how to export the video in case you did a build with an LCD. And also in that same video, probably explain how to map a 3-position switch like this one here is the TV, flare, and DVO switch. As you can see, it's only 2 buttons because the center position is off, but that is very easy to configure in DCS. You need to have kind of a button press in between. So this is down, this is up, and this is in the middle. And as you can see, there's nothing being pressed except 77, which is the on-off rotary switch. But there's nothing in the middle. And that is very easy to set up in DCS. So I may do a video to configure the TEDAC specifically for DCS. But for the time being, you have a working unit and you can start playing. So I hope you enjoyed the series. Next video, as I said, is going to be the programming of the software for port expander builds. Oh, hold on. I just forgot one thing. I remember I forgot one thing. Sorry about that. Let me just open MMJoy again. Yeah. So if you build this using PCB version 2.0, that's, if you remember, that's a button matrix. So the pins coming out are labeled as R1, R2, R3, and then columns 1 to R stands for row, and columns C1 to C7. So what you would need to do is in the buttons section, there is a button matrix section here. And same as before, if you connected, for instance, I think I explained, I don't remember now the connection, but let's say that we connected 2, 3, and 4. I think we connected maybe these ports here. I don't remember the pins right now, but let's say that rows were these 2 pins, which are D3 and D2, and then D1, so D1, D2, and D3. And then columns are 3, 4, 5, 6, 7, 8, and 9. So that's 7 columns. And these are the pins, so D0, D4. That's exactly the same. So you would type in here the pins. I ignore this. I just used these are for the rotary switch, but the thing is that you would connect the row pins here, the 3 row pins. So it would be, let me just move this a little bit aside. It would be D3, D2, and D1. And then the columns would be D0 and D4, and you get the point, right? And that's where I said you could connect them wherever however you want. You didn't need to follow my exact schematic. You just need to connect 3 pins for the rows and 7 pins for the columns, because you will then set it up here, and it will be based on how you connected it. So don't need to follow exactly my schematics. And one more thing, the reason I do have from the right, the reason I do have values here is because I connected the rotary switch directly to the board. I didn't connect it to a shift register because I believe I didn't have enough pins available, and I didn't want to add a seventh shift register. And since I had plenty, because I didn't have a button matrix for the TDU, my TDU was connected via shift register, so I'm only using this side of the board, and all these pins are available. This program has two problems. One of them is that it doesn't support port expanders, and that's why we can't use this one for port expanders. That's why we need to do it differently. So as you can see, there is no sanction for port expander. And the other thing is that it doesn't allow either, as long as I know, but as long as I can tell, it doesn't allow for single buttons to be connected. Like, I mean, I have extra pins, I could connect them to buttons individually. It doesn't allow for that. You can only connect digital inputs or buttons via a button matrix or shift registers. There's no option to just connect a button directly to the board. So what I did is connect the common of the rotary switch in pin D7, which is this one here, and then the 3 pins of each position in the next pins, and that basically is a one row matrix essentially. So it's exactly the same as connecting them separately. That's one way you can connect buttons, like the additional buttons on top. For instance, if you want to connect them separately, that's the way to do it. You connect the common pin, the common wire that you run through all of them, and you normally connect to ground in a shift register. You put it in a row, or you can do it vice versa. It doesn't matter. You could do, in my case, 3 rows, 1 column matrix. It doesn't matter. So that's one way to do it. So yeah, let me know if you have any questions. I know it's a little bit complex, but let me know if you have any questions in the comments. And as always, I will try to help you as much as I can. I hope you enjoyed the build, and also let me know if you built your unit and if it's working and how much are you enjoying it. So thank you very much for watching, and see you in the next one.